Hello everyone, and welcome back to this lecture series on BSP 303, that is Digital Systems and Applications. So in the last lecture, we have discussed about the conversion from binary to decimal and vice versa. And also we have seen some of the important like steps that how we can represent a binary number in sign and magnitude representation, along with one another technique to convert a binary digit into decimal, that is the double dead method. So in this lecture, we will continue our discussion on the number system conversion. This is the part 2 of the number system conversion. So here we will see how do we convert an octal number system into decimal or binary, and similarly a hexadecimal number system into decimal or binary. Okay, so let us begin our discussion. I'm going to share the screen, and then we will discuss about this conversion. So here you can see that this is the topic of our discussion, the lecture number 3 of today's discussion, that is we have conversion of the number system part 2, where we will see the conversion from octal to decimal, and we'll also take the example of hexadecimal to decimal or binary. Okay, so let us begin our discussion with decimal to octal conversion. All right, so let us start the conversion from octal to decimal to octal conversion. So today we are discussing the, let's fix this decimal, beginning with the first one, that is decimal to octal. Now, if you remember the decimal to binary, then it will be very easy, decimal to octal. Okay. For example, suppose I have a number in decimal. Let us say that I need to convert this 175, which is in decimal, to the respective octal. We do not know the number right now, that is to the base 8. So what we will do here, we will use the continuous division by 8, because when we convert decimal to binary, then we have divided the number by 2. So here what we will do, we will continuously divide this number by 8. So let me begin the step here. I will just first write down this number which is given, 175. Then the weight assigned or the base of the octal is 8. Just divide this by 8. Then what we will get? We will get the quotient and we will get the remainder. Okay. Now 8 into how many times? 8 into 21 times. Then what is the, you can calculate 8 into 21 times. 8 1 is 8. What do we have? 8 1 is 8. 8 168. We go to 168, isn't it? Then what is the remainder here? 168, 75. Then 7 is the remainder. Okay, remainder is 7. So in this way you will proceed further. So let me just erase this and then come back to this equation. All right. So now again in the next step, what we will do, we'll take this 21 and continuously divide by 8. 21 into 8. So 8 into how many times? You have 8 into 2 times is 16. Okay. Then what is the remainder left here? That is 5 is the remainder left. Okay. And then you have 2. Now you take this 2 divided by 8. You can't divide 8 by 2. The quotient would be 0. Then the remainder would be 2. Okay. And then you will have to go in the upper direction, that means from the bottom to the top. So your number is 175 in decimal is equal to 257 in octal. Okay. So the number is, let me just write down here, it is 257. So in this way, you can do the conversion from decimal to octal. Similarly, you can like try to solve different examples here. Now, let me tell you how will you do the fractional part. Okay, let me tell you how to do the fractional part. For example, you need to convert some fractional part into the fractional octal. Okay, then, so let me go to another example where it will make you clear about the fractional part. So in fractional parts, now you will have to just multiply by the 8, the weight assigned. Okay. So let us say you want to convert 0.15. Let us say you want to convert, this is a decimal number system. You want to convert this into octal to the base 8. Okay. So what we will do, we'll continuously multiply, like in the case of decimal to binary, what we have done, we have multiplied by the weight assigned. That's 2. Similarly here, we'll multiply 0.15 into 8. Okay. So what do we get here? We get 1.2. And then you have to note down this, the integer part. Okay, just note down the integer part. All right. Then what do we have the fractional part here? It is 0.2. So I'll go to the next step, that is 0.2 into 8. So 0.2 into 8, that is 1.6. Okay. Then 0.6 here. From here again, you take 0.6 into 8. Okay. So this 0.6 into 8 is nothing but 4.8. Okay. Now again, you come with 0.8 into 8. So this 0.8 into 8 is 6.4. 6.4. Now you have 0.4 here. So it is 0.4 into 8. Okay. This is nothing but this is 3.2. And back again, you come to this 0.2 again. So this is repetitive. Okay. So in other words, what do I say? That it is 11463, then again 11463, then again 11. So this is repetitive. So therefore, what do I write? I write that this is equivalent to, so 0.15 to the base 10. So this is equivalent to, and this is equivalent to, you need to take this number. Okay. And this number would be repetitive because you see that here it is 0.2 and after this it is repeating, isn't it? So similarly in this case also. So it is approximately, we'll just approximate this. It is approximately equal to 114. So this is 0. Okay? This should be point here. Sorry for that. So this is 0.11463 to the base 8. Okay. So this is how you are going to write the conversion from a fractional decimal number into a fractional octal number. Okay. Now let us go to the next one. That is, how would you convert? You know that how would you convert this binary to octal? Binary to octal. Binary to octal conversion. Let us see this. All right. So now they can be converted into its binary number can be converted into its equivalent octal numbers by making a group of 3 bits. Okay. यहाँ पर क्या करेंगे हम 3 bits का उसका group बनाएंगे. ठीक है ना? We'll make a group of 3 bits starting from LSB. So you will have to make this 3 bit group starting from LSB. Starting from least significant bit. Okay. Then add necessary zeros if needed. Okay. Zeros may be required to complete the group. So whenever you are doing conversion from binary to octal, just make a group of 3 and do the conversion. For example, suppose the question is you need to convert to octal. So the question is you need to convert 100 1110. So this is your binary number. Okay. You need to convert this into its equivalent octal. Okay. You need to convert this to octal. So you need to make a group of 3. Let me use a different color here. Starting from LSB, you know that see this 0 represents the LSB. So from here you make a group of 3. This is 1, 2, 3. This is one group. Okay. This is the first group, and again 1, 2, 3. This is the second group. So this same number, what I would do now, I would write in this way. So let me write this And now here you see only one single one is there. So if necessary, you can add 2 zeros here. ठीक है ना? तो इसको हम now just let me try to write this portion here. Okay, so this is 0 1 1 0. So this is nothing but this is 1 1 0. This is one group, and the second group I will write it here, that is 0 0 1. Second group it is 0 0 1. Okay, and the third group you just have a 1 here, so you add 2 more zeros to the left, so it is 0 0 1. Okay, na? So what do we get? We get 0 0 1 0 0 1 and 1 1 0. Now what is this 0 0 1? Okay, this 0 0 1 is nothing but it is 1. You can check it, do the conversion and check it. Okay. And this 0 0 1 again, this is 1, and then 1 1 0, this number is actually 6. Okay, so how would you know this it is 6 or 7? Because see, you need to use here 421 code. Okay, 421 code. For example, you are writing this 0 1 2 3 4 5 6 7. Octal number are basically represented in 3-bit information. You see here, whenever you write in 3-bit information, that represents your octal number. Okay, now 0 1 2 3 4 5 6 7. You need to use this 421 code. First start writing from 4 0 0 0 0 0. Then you have 1 1 1 1. Unlike the binary like BCD, we have used 8421 code. So for octal we will use 421 code. Okay, and again 2 zeros and 2 1s, 2 zeros and 2 1s, 2 zeros and 2 1s. Okay, and then at the end you have a single 0 and single 1, single 0 single 1, single 0 single 1, similarly to the last. So now here you see 0 corresponds to 0 0 0 0. Okay, and then 1 corresponds to 0 0 1. Similarly 2 you have 0 1 0. So from here you can easily pick up and place the values here. Okay, so this octal number which is given here in the question, this is equal to, I can write 116 to the base 8. So this is how you are going to do the conversion from binary to octal. Just remember that when you are doing the conversion from binary to octal, you have to make a group of 3 starting from the LSB, which is the rightmost digit. Okay, you just need to make this into, place this into group of 3s. All right, so the rules there are rules for doing the fractional part. So for fractional part you will have to start making the group from the right to the left. From the left to the right. You will have to start making the group from the left towards the right. Okay, in that way you can do the conversion for the fractional part. All right, now if you compare this octal number with decimal and binary, then I can draw a big master table for this one, writing all these the binary and the octal number system for every value. Okay, so let me do that. So first and foremost, let me write down the octal number system. Then I will write down the equivalent decimal. ठीक है ना? Then उसके बाद मैं क्या करूँगा, मैं इसका equivalent binary number लिखूँगा. ठीक है? Now, if you remember this table, then it will be very easy for you to convert from octal to either binary or from decimal to either binary. Like immediately you can do the conversion. Okay, so let me start 0. Octal number system, 0 1 2 3 4 5 6. Then you have 7, isn't it? These are the octal number system. Okay, then what is the equivalent decimal of this number system? What is the equivalent decimal number system? For 0, then decimal number is also 0. For 1, it is also 1. Similarly for 2, 3, 4, 5, 6, 7. ठीक है ना? अभी second, now 7 के बाद, after 7, what is the next what is the next octal number? 8 is not the octal number system. Similarly, not 9, but 10 is the octal number system, because 10 includes 1 and 0, and you have 1 here and 0 also here. So the next 2-digit octal number system is not 8, not 9, but directly write down 10. Okay, na? And what is the next decimal? Next decimal it is 8. Okay. Now next octal it is what? 11. Okay, na? And next decimal kya hoga? 9. Similarly, you can write all the values up to 17, 15. Okay. यहाँ आपको 0 से लेके 0, 1, 2, 3 ये आप लिख सकते हो. 9 के बाद नेक्स्ट डेसिमल क्या होगा? 10 होगा, क्योंकि 1 भी डेसिमल है. Okay, 1 is also decimal and 0 is also decimal. So the next decimal is also 1 and 0. Okay, the next decimal is 1 and 0. Now let me write down the binary equivalent of this, all these numbers. Now you know that 6, then I have 7, 8, 9. Okay, na? So see, for 0 binary number, what do you have? So this is 0, 0, 0. Okay. Now 1, you know that from that earlier table it is 0, 0, 1. Okay. Then it is for 2 it is 0, 1, 0. Both are equal. The octal is also equal and the decimal is also equal. Now for this one it is 0. For 3 it is 0, 1, 1. And for 4 it is 1, 0, 0. Okay. For 4 it is 1, 0, 0. Now for 5 it is 1, 1, 1. Sorry, 1, 1, 0. For 5 it is 1, 1, 0. Then for 6 it is 1. Sorry, for 5 it is 1, 0, and 1. Okay. And for 6 it is 1, 1, 0. Okay. Now for 7, this is the maximum octal number, that is 1, 1, 1. For 7, this is 1, 1, 1. Now the next octal is 1 and 0. That represents the corresponding decimal 8. Now what is 1? 1 is nothing but it is 0, 0, 1. Okay. Let me first write down 1, that is 0, 0, 1. Okay. And then 0. What is 0? Now 0 is 0, 0, 0. Okay. Now this 10 in octal, it is equivalent to 8 in decimal, and that is equal to 0, 0, 1, 0. I'm writing each octal number in 3-bit information. Okay. Like here I have 1, 0, then I'm writing 1 is 0, 0, 1 and 0 is 0, 0, 0. Similarly for 9, the octal equivalent is 1 and 1. So for 9 I can write 1 and 1, that is 0, 0, 1, and again I can write 0, 0, 1. Okay. So this is how you can write down the equivalent octal and equivalent decimal and binary. Now if you know this master table, if you can write this master table for a long value, then you can, if there is any question in your examination like to convert the octal into binary or decimal into binary, then you can directly see from this table. Okay, fine. So these were some of the conversion. Now let me go to the hexadecimal number system and make a master table first. Okay, which will make you, which will make things very, easy if you make the master table. Fine. Just like this, I will make another master table. That is, okay, let me start from here. ठीक है ना. तो सबसे पहले मैं क्या करूंगा, हेक्साडेसिमल. ठीक है, हेक्साडेसिमल का लिखूंगा, उसके बाद में फिर डेसिमल. This hexa means it is hexadecimal. Okay, then this is decimal, then this is binary. All right, ठीक है. Now hexadecimal and decimal up to 9 तो they are same, isn't it? So 9 तक देखो 0 है, फिर then you have 1, then you have 2, then you have 3, 4, okay, 5, then you have 6, 7, 8, 9. Now after 9, what is the next hexadecimal number? That is A. Okay, and then you have B. Now similarly, the decimal equivalent of this one, 2, 3. Just write this line so that it will be easy for me to write this values. Now the decimal equivalent of 0 hexadecimal is, decimal is also 0. Then 1 up to 9, it is exactly same. So let me just write down 5, okay, 6, then 7, 8, 9. 9 तक बिल्कुल सेम है हेक्साडेसिमल और डेसिमल का रिप्रेजेंटेशन. 9 के बाद में नेक्स्ट डेसिमल नंबर क्या है, 10 होगा. ठीक है, because you have 1 also in decimal and you have 0 also in decimal. So after 9, the next decimal number is 10, and then similarly 11. Okay. So now you write down the equivalent. Whenever you are writing hexadecimal representation of a number, then see, whenever you are writing octal, then you are writing by 3-bit binary information. Okay. So whenever you are writing for hexadecimal, you have to write that by 4-bit binary. Every single digit you will have to represent by, in this case, it would be represented by 4-bit. Okay. So that means it is 84214 code again. Okay. So we'll just have to use this 84216. Then I have 7. Then I have 8. Then I have 9. Then the hexadecimal is A and decimal is 10. They are equal. Hexadecimal B and decimal 11. They are exactly equal. So now here I'm writing the coded information, and I'm again using the 8421 code. Okay, this is a 4-bit information, so I'm writing by 8421. So first I'm writing 8 zeros, 1 2 3 4 5 6 7 8. ठीक है, फिर उसके बाद में 8 ones होना चाहिए, लेकिन यहाँ पर सिर्फ हम 4 ones लिख सकते हैं क्योंकि इसके बाद का नंबर हमने नहीं लिखा है. Okay, now 8 and again 4 0 0 0 0 0, then again 4 1 1 1 1 1, then you have 4 zeros, 1 2 3 4. Okay, and now 2 zeros and 2 ones, again 2 zeros and 2 ones. Now again you have 2 0 and 2 1. Now alternately 0 and 1 are placed like this. 0 1 0 1 0 1 0 1. Now if you can write down this table up to 15 or 16 for up to 15 for decimal, then it would be up to F for hexadecimal. You can do it. You just follow this 8421. Okay. Now in this way, if you remember this table, this you can call this as the master table. Then whenever the question is to convert this hexadecimal into binary, just see this number and directly convert it. Okay. You can also do in that. Fine. So anyways, let us go and see how we can do the conversion from hexadecimal to decimal, not binary, but from hexadecimal to decimal. Okay. So the next part is the conversion of hexadecimal to decimal. Let me go to the next page actually. All right. So let me note it down here. Hexadecimal to decimal. Okay, hexadecimal to decimal. Fine. So suppose I have this, for example, I have this number 3a.2f. So I have this number 3a.2f. Okay. So I need to convert this hexadecimal number to the base 16 into, I need to convert these to to the base 10. Okay, to the base 10. So what would I do? It's quite simple again. If you remember the conversion from any number into decimal, then what would you do? You multiply this by the respective weight assigned. Okay, suppose first number is 3. So क्या करूँगा मैं 3 into इसके weight assigned. Now you are doing the weight assigned to this is 16. Okay, so what would you do? You will multiply this by the 16 into 6 a. Now this a is 16 to the power 0 and this 3 is 16 to the power 1. So 3 into 16 to the power 1. Okay, plus a. Now what is a in decimal? If you see this master table back here. Now this a in decimal, it is what? You see this step. A in decimal is 10. Okay, so instead of a, you can just write that is 10. Okay, so here what I will write, 10 into the weight assigned 16 to the power 0. Okay, 10 into 16 to the power 0 plus now 2 into 16 to the power minus 1 plus f. Now f in decimal is nothing but it is 15. Okay, f in decimal is 15. So I'll just write this as 15 into 16 to the power minus 2. That's it. So now you just need to calculate this, and the calculation part is not very difficult. So anyway, let me just write down the values here, what we are getting. So this is 16 to the power 16. So I will have this 16 into 3. How much this is? 48. Okay, so yes, this is 48 plus 16 to the power 0 is 1. 10 into 1 is 10. Okay, so this is 10 plus, इधर आपको क्या मिलेगा, 2 न्यूमरेटर में, डिनोमिनेटर you can take this to the denominator, it would be 2 divided by 16 to the power 1, and 16 to the power 1 is just 16 plus ये होगा तुम्हारा 15 divided by 16 to the power 2. Okay, now you can just write this as 16 to the power 2 here. Fine. Okay, so now you just simplify this. Okay, the next step is just to simplify. What is 48 plus 10? 48 plus 10 is 58 plus 2 divided by 16. Okay, and 15 divided by 16. If you add, I mean, all these together, you will get 0.1836. Okay, so you will get here 0.1836 if you check this with your calculator. Okay, so therefore this implies that it is 58 plus 0.1836 is 58.1836 to the base what, 10, to the base 10. So in this way, an hexadecimal number can be, you see this hexadecimal number is now converted into this decimal number where we do not have any characters now. Okay, we only have the numbers. Similarly, one can do the one can do the conversion from the vice versa of this one. That means the decimal to hexadecimal conversion. Okay, so chalo, let us see some example of decimal to hexadecimal conversion. So the next part is that is let me just write down here, decimal to hexadecimal. Decimal to hexadecimal conversion. Okay, na? So we will begin with one simple example. I will just discuss one example, that is I need to convert, let us say I need to convert 95.5, which is to the base 10, to some numbers into base 16. Okay, and I need to find out this number. What is this hexadecimal? Now I will do this separately for integer part. यहाँ पर आप लोग देखो मैं दूसरा कलर यूज कर रहा हूँ, ये ब्लू कलर इंटीजर पार्ट के लिए, ठीक है, और ये दूसरा वाला कलर इसके फ्रैक्शनल पार्ट के लिए. So let me go to the integer part first. So for integer part, now for integer part it is quite simple. So what would I do here? I have this 95. I will have to keep on dividing this 95 by 16 and note down the remainder. Okay, so here I have the quotient and here I have the remainder. Okay, 16 into how many times? 5 times. 16 into 5 times. Okay, and then what is the remainder? 16 into 5 times is 80. Okay, then the remainder you will have 15. Similarly, you need to divide this. Second step is to divide this 5 by 16. Okay, sorry, I need to write just 5 here, not 15. So this is 5 divided by 16. Now you cannot divide 5 by 16, so you will, the quotient would be 0. 16 into 0 is 16, and what is remaining? 16. All right. Sorry, 5 is remaining. 16 into 0 is 16, and then you have this remaining 5 here. Okay. Now this is the remainder. Now, since I need to do the conversion into, I mean, the hexadecimal, you cannot write 15 in hexadecimal. Okay, now 15 in hexadecimal corresponds to F, actually, if you see that master table, and then 5 is just 5, no change here. So then you will have to go from bottom to top in this way. Okay, so this whole 95, I'm just writing this for 95. 95 in decimal corresponds to 5F in hexadecimal. Okay, now let me use the fractional. Now let me go to the fractional. Fractional is 0.5, isn't it? So for fractional, I'm writing here For fraction, let me write it here. So fractional part, it is you have this 0.5, isn't it? 0.5 is the fraction. So what will you do? You will just multiply this 0.5 by 16. Then what is the result? The result is 8.0. Okay. Next step, next step, now you see this is 0. Now 0 into 16 would be again 0. So you will have to stop it here itself. All right. And you have to note down the integers generated. What is the integer generated? 8. So 0.5 is equal to 0.8. All right. 0.5 is equal to 0.8 in fractional. So therefore, what was our number earlier? Our number was 95.5. Okay. So therefore, 95.5 in decimal, 95.5 in decimal is equal to, now the equivalent of 95, I have shown you here, this is 5f.8. okay. So this would be nothing but this would be 5f.8 to the base 16. This is how you are going to do the conversion. Okay. Similarly, you can try out, I mean, you guys can try out with different numbers. Okay. And also there are other numbers like hexadecimal to binary conversion. So we will see that in the next lecture. And so today I will for this lecture I will stop here. So let me just stop sharing this. And then, so with this we come to the end of lecture number 3. So in the next lecture we will try to see some more conversion part is left, that is hexadecimal to binary, and then we will also try to see how we can perform different binary arithmetic, which is very important, because when we want to design an adder or subtractor circuit in digital electronics, then we need to first know this, how these binary numbers are added or subtracted from one another. That is what we are trying to cover in the next lecture. Okay. So thank you everyone, and see you all in the next lecture.